This class you work out 5 problems in magnetic circuit. Problem number 1. An iron ring has a cross-sectional area of 500 mm square and a mean diameter of 30 cm. It is wound with 500 turns. Its relative permeability is 250. Find the flux in the ring. The coil resistance is 48 ohms. Supply voltage is 240. Here supply voltage is given. Coil resistance is given. I can find what is the current flow through the coil. I is equal to V by R, 240 by 48, that is equal to 5 amps. Mean length of the magnetic circuit is equal to pi into D. Here D is given 30 centimeter. Pi into 30 into 10 power minus 2. Mean length of the magnetic circuit is equal to 0.942 meters. I can find H. H is equal to N into I by L. Here N is 500, I is 5 amps, L is equal to 0.942. Therefore H is equal to 2653.93 ampere turns per meter. I can find the flux density B. Mu is equal to B by H. B is equal to mu naught into mu R into H. Flux density B is equal to 4 pi into 10 power minus 7. Mu R is equal to 250. H is equal to 2653.93. Therefore, flux density B is equal to 0.834 Webbers per meter square. Flux in the ring is equal to pi. That is equal to flux density into cross-sectional area A. Here B is 0.834, A is 500 into 10 power minus 6. So flux in the ring is 4.17 into 10 power minus 4 Webbers. I can find reluctance S. S is equal to mean length of the magnetic circuit L divided by mu naught into mu R into A. L is 0.942 divided by 4 pi into 10 power minus 7. Mu R is equal to 250. A is equal to 500 into 10 power minus 6. Reluctance S is equal to 5.997 into 10 power 6 ampere turns per Weber. Problem number 2. An iron rod of 1 cm radius is bent to a ring of mean diameter 40 cm and wound with 240 turns of wire. Relative permeability mu R is equal to 750. Air gap length is 0.1 cm. Calculate the current required to produce a useful of 25,000 magnetic lines if A. Leakage is neglected. B. Leakage factor is equal to 1.1. Leakage factor is equal to total flux divided by useful flux. The flux developed in the air gap is useful. The flux developed in the iron part is total flux. The ratio of total flux divided by useful flux is the leakage factor. Case 1. Leakage is neglected. Length of the iron part is equal to pi into D minus air gap length. Here D is given 40 cm. Air gap length is 0.1 cm. Therefore, length of the iron part is equal to 1.256 meters. Reluctance of the iron part is equal to length of the iron part divided by mu naught into mu R into A. Mu naught is equal to 4 pi into 10 power minus 7. Mu R is equal to 750 given. A is equal to cross-sectional area. Here radius of the ring is given 1, diameter is 2. A is equal to pi D square by 4. A is equal to pi into 10 power minus 4. Therefore, reluctance of the iron part is equal to 4.242 into 10 power 6 ampere turns per Weber. Reluctance of the air gap is equal to length of the air gap, that is 0.1 into 10 power minus 2. Mu naught 4 pi into 10 power minus 7. Mu R is equal to 1. A is equal to pi into 10 power minus 4. Reluctance of the air gap is equal to 2.533 into 10 power 6 ampere turns per Weber. Total reluctance is reluctance, that is SI, reluctance in the air gap plus reluctance in the iron part. SI plus SAG, that is equal to 6.775 into 10 power 6 ampere turns per Weber. Now I can find MMF. MMF is equal to pi into S. Here leakage is neglected. Pi is 25,000 into 10 power minus 8. Reluctance is 6.775 into 10 power 6. MMF is equal to 1693.75. I can find I. I is equal to MMF by N. N is given 240. I is equal to 7.06 amps. In case of leakage is neglected. Case 2 including leakage. Now we have to find the total flux in the iron. Total flux in the iron is equal to leakage factor into 25,000 into 10 power minus 8. Total flux available in the iron is equal to 2.75 into 10 power minus 4 Webbers. MMF in the iron path is equal to total flux into reluctance of the iron path. 2.75 into 10 power minus 4 into 4.242 into 10 power 6, that is equal to 1166.55 ampere turns. Similarly, MMF in the air gap is equal to 25,000 into 10 power minus 8, that is a useful flux, into 2.533 into 10 power 6, that is equal to 633.25 ampere turns. The total MMF is equal to MMF in the iron path plus MMF in the air gap, that is equal to 1799.8 ampere turns. MMF is MMF divided by N. So 1799.8 divided by number of turns 240. I is equal to 7.5 amps including the leakage flux. Problem number 3. An iron ring is made of two different materials A and B. Relative permeability of A is 1000. Relative permeability of B is 1500. Mean length of A is 80 cm. Mean length of B is 30 cm. Air gap length is 2 mm. Number of turns is 1000. Exciting current is 6 amps. Calculate flux produced in the air gap. Cross-sectional area is 10 into 10 power minus 4, that is 10 cm square. First step, we have to find the reluctance of A, reluctance of B, and the reluctance of the air gap. Total reluctance is equal to SA plus SB plus SAG. MMF is equal to N into I, 1000 into 6, that is equal to 6000. Reluctance of the material A is equal to L1 divided by mu naught into mu R into A. L1 is equal to 80 into 10 power minus 2, mu naught is equal to 4 pi into 10 power minus 7, mu R is equal to 1000, A is equal to 10 into 10 power minus 4. So reluctance of material A is equal to 6.366 into 10 power 5 ampere turns per Weber. Similarly, reluctance of the material B is equal to 1.592 into 10 power 5 ampere turns per Weber. Reluctance of the air gap is equal to 15.915 into 10 power 5 ampere turns per Weber. The total reluctance is 23.843 into 10 power 5 ampere turns per Weber. Pi is equal to MMF by total reluctance. 6000 divided by 23.843 into 10 power 5. That is equal to 2.516 into 10 power minus 3 Webers or 2.516 milliwebers. Problem number 4. A magnetic circuit having 3 coils is shown in figure. This is the figure. This is coil 1, coil 2, coil 3. It has a cross-sectional area of 1 by 1 centimeter square. Each limb is 1 centimeter wide and the inner window dimension is 2.5 by 2.5 centimeter square. The coils have N1 is equal to 20, N2 is equal to 40, N3 is equal to 20. They are carrying DC currents. I1 is equal to 2 amps, I2 is equal to 1 amps, I3 is equal to 3 amps. Relative permeability mu R is equal to 1000. Determine pi, flux density B and the magnetic field intensity H in the core. Here this is coil 1. The current direction is towards the coil. This is leaving the coil. This is positive, this is negative. Here this is positive, this is negative. Here this is positive, this is negative. MMF is equal to N1 into I1 plus N2 into I2 minus N3 into I3 because the third coil produces the flux in opposite direction to that of the other coils. Hence I put minus sign. MMF is equal to 20 into 2 plus 40 into 1, 3 into 20, that is equal to 20 ampere turns. The total MMF is 20 ampere turns. I can find the length of the magnetic path. Here this length is 2.5. The each limb wide is 1 centimeter. This is 0.5. This is 0.5. This is the green is a magnetic flux. Therefore 2.5 plus 0.5 plus 0.5, that is equal to 3.5. This length is 3.5. 3.5 into 4, that is equal to 14 centimeter. Reluctance S is equal to L by mu naught into mu r into A. Mu naught is equal to 4 pi into 10 power minus 7. Mu r is equal to 1000. L is equal to 14 into 10 power minus 2. A is equal to 1 into 10 power minus 4. Reluctance S is equal to 1.114 into 10 power 6 ampere turns per Weber. Now I can find pi. Pi is equal to MMF by S. Yeah, S is a reluctance. MMF is 20. S is equal to 1.114 into 10 power 6. Pi is equal to 1.80 into 10 power minus 5 Webers. Flux density B is equal to pi by A. Pi is 1.80 into 10 power minus 5 divided by 1 into 10 power minus 4. That is equal to 0.18 Webers per meter square. Magnetic field intensity H is equal to MMF by length. MMF is 20. Length is 14 into 10 power minus 2. Magnetic field intensity H is equal to 142.86 ampere turns per meter. Problem number 5. A toroidal is made up of 3 ferromagnetic materials and is equipped with a coil having 200 turns. Material 1 is nickel iron alloy having a length of 0.3 meters. Material 2 is medium steel and has a length of 0.2 meters. And material 3 is cast steel of 0.1 meters. Each material has a cross-sectional area of 0.001 meter square. Find the MMF required to establish a magnetic flux of 6 into 10 power minus 4 Webers. Calculate the coil current and compute relative permeability mu r and the reluctance of each material. We know that flux density B is equal to pi by A. Here pi is 6 into 10 power minus 4. A is equal to 0.001. Therefore B is equal to 0.6 Tesla or 0.6 Webers per meter square. Here the cross-sectional area is same. Flux density is same in all materials. We have to find the value of H. H value can be obtained from the BH curve. Nickel iron H value is 10 ampere turns per meter. Medium steel H value is 77 ampere turns per meter. Cast steel H value is 270 ampere turns per meter. The total MMF developed in the toroidal is H1 into L1, H2 into L2, H3 into L3. 10 into 0.3 plus 77 into 0.2 plus 270 into 0.1, that is equal to 45.4 ampere turns per meter. That is the MMF developed in the toroidal. MMF is equal to N into I. Here N is given 200. I can find I. I is equal to 45.4 divided by 200. That is equal to 0.227 amps. Next is I can find the relative permeability of nickel iron. B divided by H1 into mu naught. H I know 10. Mu naught is equal to 4 pi into 10 power minus 7. B is equal to 0.6. Mu 1 is equal to, that is the relative permeability of nickel iron is 47.75 into 10 power 3. Similarly, mu 2 is equal to B divided by H2 into mu naught. H2 is 77. B is 0.6. Mu naught is equal to 4 pi into 10 power minus 7. Mu 2, that is the relative permeability of medium steel is 6200.84. Relative permeability of cast steel is 0.6 divided by 270. H3. H3 is 270. Into 4 pi into 10 power minus 7, B is 0.6. That is equal to 1768.39. I can find the reluctance of nickel iron. That is MMF by pi. MMF is equal to 10 into 0.3. 3 divided by 6 into 10 power minus 4. That is equal to 5000 ampere turns per Weber. Reluctance of the material medium steel is MMF 77 into 0.2, that is equal to 15.4 divided by pi, 6 into 10 power minus 4, that is equal to 25.67 into 10 power 3 ampere turns per Weber. Here reluctance of the cast steel, that is mm of 270 into 0.1, that is equal to 27 divided by pi, 6 into 10 power minus 1, that is equal to 45 into 10 power 3 ampere turns per Weber. With this, I conclude my lecture. Thanks for listening.